So this was, I believe this was 2015, the series question, which they're pretty much always non-calculator questions. So we're given a Maclaurin series, -3 to the n minus 1 times x to the n over n. They give us the first few terms there. And we need to use the ratio test to find the radius of convergence. So start with on part A. We'll do the limit as n approaches infinity of the absolute value of -3 to the n plus 1 minus 1, which will just be -3 to the n times x to the n plus 1 over n plus 1 times, and then just the reciprocal of that, n over -3 to the n minus 1 x to the n. And as we simplify that out a bit, what does that turn into? So the limit as n approaches infinity of the absolute value of -3 to the n over -3 to the n minus 1 should just be -3. N is just n. We should also have an x up there, x to the n plus 1 over x to the n. And we should have an n plus 1 in our denominator. The absolute value of the -3 just becomes a 3. And so n over n plus 1 should give us what? Should give us the absolute value of 3x. And so we'll let that be less than 1, which tells us the absolute value of x is less than 1/3, which should tell us that our radius of convergence is 1/3. Everybody good there?
Yes.
All right, and let's see, that one was worth 3 points. It looks like 1 for correctly setting up the ratio, 1 for finding the actual limit of the ratio, absolute value of 3x, and 1 for the final radius of convergence. Okay. Any questions on part A? No? Okay. So part B then asks us, I guess I should look at it here. Part B says to write the first 4 non-zero terms of the Maclaurin series for f prime, which is the derivative, and then we want to express f prime as a rational function for its radius of convergence. So we could start off just by term differentiating, or we could differentiate our actual series itself. Doesn't really matter which way you want to go with it here. But if we just go term by term, what's the derivative of x?
1.
Should be 1. And our second term was -3 halves x squared. So what should that give us? Should give us a -3x. Next term, which was 3x cubed, should give us 9x squared. And they didn't give us the next term, but if n was, let's see, this was n was 1, n was 2, n was 3. If n was 4, right, what would we be looking at? We'd be looking at -27 x to the 4th over 4. And so -27 x to the 4th over 4, its derivative should be -27 x to the 3rd. And those are the first 4 non-zero terms. That's our f prime of x. Everybody good with that? And what does this series in its general term look like? is a sum from n equals 1 to infinity of what? X to the n minus 1, right? And yeah, negative, I was going to say negative 3 to the n minus 1, x to the n minus 1, or negative 1 to the n 3x to the n. Yeah, if we started at n equals 0, we could start at n equals 1 and call them n minus 1s. It doesn't really matter. And so what is the common ratio here between the terms? This is just a geometric series, isn't it? With a common ratio of negative 3x, right? And so this should be f prime of x equals our first term, 1, over 1 minus negative 3x, or 1 over 1 plus 3x. And so we could say that is the function for f prime of x, 1 over 1 plus 3x. And let me see, that was worth 3 points. So you got 2 points for this, which is pretty generous because that's pretty easy to find, I think. And this also is, but 1 point for the correct function. Any questions on part B? All right. And let's see there. We could have written it if we wanted to, Nick. We could have said n equals 0 to infinity of negative 3x to the n, or n equals 1 of these, or n equals 2 of n minus 2s, or n equals 3 of n minus 3s. It doesn't really matter. Any of those would be fine. You can always manipulate the powers to match whatever index you want it to be. Yeah, this would be fine. Or then, that's fine too. Okay, part C says to write the first 4 non-zero terms for the Maclaurin series for e to the x. Oh, that part ought to be exceptionally easy. That's one that you should know, right? E to the x is x to the n over n factorial. So our first, what did it say, 3 or 4 non-zero terms? First 4 non-zero terms. So e to the x should be, first term should be 1. Well, that's right. Just to make sure we are aware of what it is. And x to the n over n factorial. You really need to have that memorized. You really need to know that one. And so our first term should be 1 if n equals 0. When n is 1, our next term is x. When n is 2, it should be x squared over 2. And when n is 3, it should be x cubed over 6. So that's the first part of that. That part should have been very easy. Just writing the terms is fine because it doesn't ask for the general term. It just says write the first 4 non-zero terms. So you don't need the general term. It'll specify to write the general term if they want you to write the general term. I just put it up here just to be like, all right, everybody make sure you know that. And then it says use that series to write the 3rd degree Taylor polynomial for g of x, where g of x is e to the x times f of x. So we are looking at e to the x times this function up here. And we want the first 4 non-zero terms. So really all we have to do to find e to the x f of x is take the terms of e to the x and multiply them by the terms of f of x. So what's that? X minus 3 halves x squared equals an x1 plus 3x cubed, and so on. And so if we just distribute all of this stuff through to get the first 3 terms, right? So it said third degree, right? Yeah, third degree Taylor polynomial. So we just got to distribute through until everything is at least as a high power of 3. So over here, we don't need any x to the 4th terms because multiplying x to the 4th by the 1 is always going to make it more than third degree. So I can ignore anything with x to the 4th. And really, I don't even need this x cubed over 6 term here because that's going to give me terms that are beyond a third degree, but that's fine. So we will say that the third degree Taylor polynomial ought to be, let's see, 1 times x is just x. Then you got negative 3/2 x squared. And then well, I'll write more of it out. Negative 3/2 x squared. And we're going to have a 3x cubed. And we're going to have an x squared. And we're going to have a negative 3/2 x cubed. I don't need the x to the 4th term. Don't need to worry about that at all. And let's see, x squared over 2 times the x is going to be x cubed over 2. And x squared over 2 times this is going to be to the 4th term, so I can ignore that one. And we should then just be able to say that it is x minus 3/2 x squared plus x squared. That'd be minus 1/2 x squared. And then if I combine all my cubes here, I've got 3 minus 3/2 should be 3/2 plus a half should be 2. So plus 2x cubed. And that is our third degree Taylor polynomial for e to the x times f of x. And let me see, let me look down here. What's our point breakdown? 1 point for this and 2 points for this. So overall, how'd you guys do at that? 7 out of 9. Yeah, 7 out of 9 is not bad. Could be a lot worse. And like I think I've told you guys before, 6 out of 9 is putting you on track pretty much for a 5. You get 6 out of 9 on all the free response. Did the last part wrong? As in the last part of the last part of C? Yeah, they wanted the polynomial itself. So you got to multiply the terms by the terms, right? Because you're looking for a polynomial. But now you'll be good with that. So, any other questions on that one? Everybody good there? All right, we definitely have time to do another one. So let's take a look at this one. This one's got a little error bounding at the end of it. So I'll put a timer on for another 15 minutes and give you guys 15 minutes to work through this one. And then we should have plenty of time to talk about it afterwards. So ready, go. So I'll just real quickly say that again in case anybody didn't understand when I forgot to record. First term is f of 1 times x minus 1 to the 0 over 0 factorial. Second term is f prime of 1, negative a half times x minus 1 to the first over 1 factorial. Then we use the formula for the nth derivatives. So negative 1 to the second, 2 minus 1 factorial, 2 to the second, x minus 1 squared over 2 factorial for the Taylor series part of it. And same thing here, negative 1 to the third, 3 minus 1 factorial, x minus 1 to the third over 2 cubed, 3 factorial. And then the nth term is just this times x minus 1 to the n over n factorial. And you can simplify the n minus 1 factorial over the n factorial to just an n in the denominator. Yeah, so Adrian, that's a good question. It only works for n greater than or equal to 2. And so when we go about writing out our series and looking for the interval of convergence, we need to be careful about how we write it. So if we were to write this thing out as a series, just the whole thing, I would write it like this: 1 minus 1/2 of x minus 1 plus the sum from n equals 2 to infinity of all of this stuff, -1 to the n, x minus 1 to the n over n times 2 to the n. If you were to write it out as this whole thing, n equals 0 to infinity, without these terms at the beginning, you'd have the issue of dividing by 0 there at n equals 0, which would be a problem. So you could do it with n equals 1. I suppose we could just do 1 minus n equals 1 to this. This would be fine too. We could say 1 plus. This would also work. And we could, if we wanted to drop this index down to 0, we could, let's see here. Yeah, I don't think I don't see a good way right off the bat to do that. So this is how I would write it, most likely. But I don't think it asks us to do that anywhere in here, so you're kind of good on that. Does that answer your question, Adrian? Hopefully that's good. Okay, so for part B, so there's 4 points there for part A. So for part B, what did it ask us to do there? So it has a radius of convergence of 2. Find the interval of convergence. Okay, so if it's around x equals 1, we'll say it's at x equals 1 with a radius of convergence of 2. That should tell us that the base interval of convergence for this should be -1 to 3, which means to find the actual interval of convergence, we need to test the endpoints at x equals -1 and x equals 3. So in order to do that, we'll just take a look at what happens at x equals -1. And at x equals -1, if we just look at this, we've got 1 plus, and then if x is -1, this is -2 to the n. So we got -1 to the n, -2 to the n. And what was in my bottom there? N and 2 to the n. And we can take out the -1 from this. So this is -1 to the 2n. Then we have a 2 to the n over a 2 to the n over an n, which cancels. So we just have -1 to the 2n over n, giving us this. We still have the 1 plus in front of it. But a 1 plus in front of it's not going to affect this. This is what series? This is the harmonic series. So we can say this diverges by the p-series test. And then at x equals 3, we end up with 1 plus the sum from n equals 1 to infinity of -1 to the n, 2 to the n, over n, 2 to the n, which is the sum from n equals 1 to infinity of -1 to the n over n, which we know converges by the alternating series test. since it's just asking for the interval of convergence, it doesn't specifically say anything about absolute convergence or conditional convergence. We can then state that this converges for -1 to 3, inclusive of the 3, but not the -1. Everybody good there? And you got 1 point for this, identifying that the endpoints were -1 and 3, and 1 point for that. Any questions on that? We'll fly through parts C and D here because they're pretty straightforward. Part C just says this can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms to approximate f of 1.2. So our first 3 terms were 1, and then -1/2 times x minus 1. And then let's see, what was the other one? We had a -1 to the n, right? So -1 squared. We had that'll give us a 0.2 to the n. And a2 times a2 to the n. And so we just approximate all of that out. This is 1 minus half of 0.2, so 1 minus 0.1. And then this is plus, this is a 1. Oops, this is 0.2 squared. I forgot to rewrite that. And what is all that in this last little piece here come out to be? That should be 0.2 squared over 8. I don't even know. I mean, plus, and that should be 0.04 over 8. And whatever that comes out to be. I guess I could look at the scoring guide. That comes out to be 0.905. And that's just 1 point for part C. And then part D asked us to show that our approximation is within 0.001. Well, that should be pretty straightforward also, because we know that since this is an alternating series, the error bound, our error is always less than the next absolute value of the next term. And so our next term would just be our series evaluated at 3. And if we take our series and evaluate it at 3, take the absolute value, that's -1 cubed. We end up with a 2, I believe, up there. Where did our series go? Yeah. Where was our original series? There it is. Okay. So -1 to the third, and then 0.2 to the third, and 3 times 2 to the third. And that should come out to be, let's see, that's 2/10, that's a fifth, so that's 5. That's a 1 over 125 times 24. That's 125 times 24. Anybody have that off the top of their head? $3,000. Perfect. So 1 over 3,000, and since 1 over 3,000 is less than the value that they asked us to show that it's within, it's less than 1 over 1,000. That proves that we're within 1 over 1,000. And so that was worth 2 points there. 1 for stating that the error was less than the next term because it was an alternating series, and 1 for showing rest of that. Anybody have any questions on that? That makes sense now. Sorry, we went a little over there again. Everyone good?